In this video, we're asked to write a method called flip, and we're going to add it to an int_tree class. This method reverses the tree about its left and right axis, so that any node that used to be its parent's left child will now become its parent's right child, and vice versa. So as you can see, before we make the call to our flip method here, this is what our tree looks like, and when we call it, we can see that everything is kind of flipped here. The 52's left child used to be 99. Now it doesn't have a left child, but its right child is now 99. And as you can see, the 52 subtree is now on the left side as opposed to right side. Okay, so if a tree has no nodes or is a leaf, we should not affect it with our call, so nothing to do there. And we have access to the data field, the left and the right fields of the int tree nodes, and we have access to the entry through our overall root. So let's get started here. We're not returning anything in the flip method here, so we're just going to call it flip. We're going to use the property of xChangeX to change the trees. And because we're only flipping the tree, we only have to deal with one parameter, and that'll be the root that's passed in. Okay, but because we're using xChangeX and we're changing our int tree nodes, we need to have a return type in our private method of int tree node flip. It's going to take int tree node, call it node. Okay, so what do we need to do here? Okay, so what happens if node is equal to null? Well, we actually don't do anything at this point. Okay, so we don't actually need to deal with that case. We need to deal with a more interesting case to see what if the node is not equivalent to null? Then in that case, we need to implement our flip methods here. So how are we going to do this? Well, let's create a temporary variable here. A temporary variable so that we don't lose the sight of our node. And we're going to say, okay, that's going to be equivalent to the flip of traversing through the left side of the subtree. Now that we've stored the left tree, what we can do is we can now say, let's change our left subtree to be equivalent to the right subtree, and the way we're going to do that is we're going to call the flip method, and we're going to traverse through the right side. So that'll change that, and remember, because we did this thing, we lost sight of the entire left subtree, but because we kept a temporary int tree node, we have all those values stored in our temporary value here. So our right subtree will now become the left subtree, so we're going to set that equivalent to the temporary value. And then after that, we break out of this, and the last thing we want to do is we want to return our node so that we actually start changing the tree and we start getting the reverse. Anyhow, that'll be it for this video, and I'll see you guys next time.